Is there anything on Earth more powerful than nuclear weapons? Maybe a substance that, even in a microscopic amount, could unleash unimaginable destruction. The destructive potential of antimatter is almost beyond belief. Just half a gram of antimatter could create a blast comparable to the bomb that destroyed Hiroshima, and about 1.5 kilograms of antimatter could surpass the record of the thermonuclear Tsar Bomba, which was tested on Novaya Zemlya in 1961. Such a substance with extraordinary destructive power truly exists. Back in 1928, the British physicist Paul Dirac proposed the idea that particles might have counterparts with the opposite electric charge. 5 years later, Dirac received the Nobel Prize for this groundbreaking prediction. The first antiparticle was discovered in 1932 by the American physicist Carl Anderson. This discovery revealed the positron, a positively charged counterpart of the electron. This strange mirror version of matter has fascinated scientists ever since. When antimatter collides with ordinary matter, the two completely annihilate each other. Their mass is instantly converted into energy, producing an intense burst of radiation. The physicist Frank Close from University of Oxford wrote in his book about antimatter that the annihilation of just 1 kilogram of antimatter would release roughly 10 billion times more energy than the explosion of 1 kilogram of TNT. Reactions involving antimatter are about 1,000 times more powerful than the nuclear fission used in uranium power plants. But what does that actually mean in practice? The nuclear explosion over Hiroshima released energy equivalent to about 13 to 18 kilotons of TNT. It killed around 70 to 80,000 people. Almost instantly, an explosion of this magnitude devastates everything within a radius of roughly 1.5 kilometers, yet less than half a gram of antimatter would be enough to reproduce such a blast. Over time, the number of victims from the Hiroshima disaster rose to nearly 140,000 people due to radiation sickness. However, unlike nuclear weapons, an antimatter explosion would leave no lingering radioactive contamination. Calculations show that a blast with a yield of 100 megatons would create a zone of total destruction extending about 35 kilometers from the epicenter. The area of severe destruction could stretch out to nearly 50 kilometers. Such power could completely destroy any of the largest cities on Earth, and it would require only a few kilograms of antimatter. The original design yield of the Tsar Bomba was about 100 megatons. Although it was tested at roughly half that power, the result was still terrifying. The measured explosion reached about 56 megatons of TNT, an amount of energy that could be produced by the interaction of about 1.5 kilograms of antimatter with 1.5 kilograms of matter. Witnesses reported feeling the shock of the blast thousands of kilometers away. The thermal radiation caused third-degree burns even at distances of up to 100 kilometers. The shockwave from the explosion circled the entire planet 3 times the first time, completing its journey in about 36 hours. But what would happen if 10 kilograms of antimatter exploded? A similar level of energy was released during the massive earthquake that struck the Indian Ocean in 2004. The epicenter was located off the coast of Sumatra in Indonesia, and it triggered the deadliest tsunami in modern history. The earthquake had a magnitude of about 9. The movement of the Earth's tectonic plates generated waves more than 15 meters high. The tsunami devastated the shores of Indonesia, Sri Lanka, southern India, Thailand, and several other countries. Between 225,000 and 300,000 people lost their lives. Many were swept away by the retreating water into the open ocean. Even today, the exact number of victims remains uncertain. The shockwave from the earthquake traveled through the entire planet. Some Islands near the epicenter shifted by dozens of meters the massive energy release equivalent to about 480 megatons of TNT, slightly altered Earth's rotation, reducing the length of a day by roughly 68 microseconds. An explosion of about 10 kilograms of antimatter could produce a similar amount of energy. That amount of energy would be enough to boil about 150 liters of water for every person on Earth. History also remembers another catastrophe that occurred in Indonesia. The eruption of the Mount Tambora was one of the most powerful volcanic eruptions in recorded history. For 3 days, enormous clouds of ash blocked sunlight within hundreds of kilometers of the volcano. The ash later spread more than 1,000 kilometers away, causing major changes in the global climate. The following year became known as the year without a summer. Much of the northern hemisphere experienced dramatic cooling. The total energy released by the Tambora eruption has been estimated at about 20 gigatons of TNT. A comparable amount of energy could be produced by the explosion of an antimatter bomb weighing about 500 kilograms. If you want to imagine a true apocalypse, then consider the detonation of several thousand kilograms of antimatter. Such an explosion could release 100,000 gigatons of TNT. Energy on that scale could trigger a global catastrophe and potentially initiate a new ice age. Something similar happened on Earth about 65 million years ago when a massive asteroid struck the region now known as the Yucatan Peninsula. Debris from the impact shot high into the atmosphere and beyond. As it fell back to Earth, the fragments heated the air to extreme temperatures. Huge amounts of dust filled the atmosphere, blocking sunlight for years, creating conditions similar to a nuclear winter. Most scientists believe this event led to the extinction of the dinosaurs. Fortunately, creating a weapon based on antimatter remains extremely difficult. Producing antiparticles is a complex, expensive, and time-consuming process. The research organization CERN uses the Large Hadron Collider to generate and study antiprotons. Physicist Rolf Langlois explains that the low efficiency of producing antimatter is one of the main reasons such weapons are unlikely in the near future. With current technology, synthesizing just 1 gram of antimatter could cost around $1,000 trillion. Even if antimatter is produced, it must also be stored safely. The moment it touches normal matter, it disappears instantly in a burst of energy. To prevent this, scientists use extremely powerful magnetic traps that keep antimatter suspended in a vacuum. So far, the longest time scientists have managed to store antimatter is around 1,000 seconds. Still, the idea of devices capable of producing antimatter is no longer pure science fiction. Researchers at the University of Michigan have developed a compact particle accelerator, a device small enough to fit on a table yet capable of producing positrons. Compared to the enormous particle accelerators used in large laboratories, this device looks almost like a toy. It works by firing a laser through a stream of helium gas, creating a beam of electrons. When these electrons collide with a thin metal foil, positrons are produced. Magnets then separate the positrons from the electrons. Antimatter could also become the most efficient fuel ever imagined in theory. An antimatter engine could convert nearly 100% of mass into energy. Only about 10 grams of antiprotons could propel a spacecraft to Mars in roughly 1 month. Today, an unmanned spacecraft typically needs almost a year to reach Mars. The biggest obstacle to antimatter technology is simply producing it in large quantities. Throughout all the experiments conducted so far, humanity has created only a tiny amount, about 19 nanograms of antimatter in total. That is barely enough energy to boil a single cup of coffee, but what if one day we learn how to collect antimatter from space? If that happens, antimatter weapons might become a real possibility. What would the consequences be if such technology fell into the wrong hands? Could humanity prevent the creation of such weapons, or would we inevitably face the risk of their existence? Will antimatter one day destroy our civilization, or will it become the ultimate energy source that powers humanity's future?